recording again. Okay, right. Okay, now I hope that you can all see the slides correctly. There we are. Okay, so if you can all see the slides correctly, that's good. So what I want to talk about in this next bit is a little bit about abortion in the USA, because again, it's a topic that's been very highly politicized for a long time. There's been a lot of propaganda and more or less misleading things put out. Okay, so here we go. So here's, oh look, the Planned Parenthood Federation of America. Look, they're dramatically reducing the number of life-saving procedures and increasing the number of abortions. This is terrible. Okay, let's have a look at the figures behind that. There we are. Okay, so this is the same set of data over the same time period, and what we can see is, okay, so there's abortion, purple line down here. There's the pregnancy services, cancer screening, contraception, and STD treatment and testing. So that is quite a different picture. Right, okay. So if we look at public attitudes toward abortion in the US, again, we go there, and here we go. So, oh look, there's this major shift, and we come from this in 1995 to a bit of a reversal by 2009. Okay, so what do we notice about this? First of all, we are starting the graph at, we've got the graph going between 30 and 60%. Okay, so this, obviously by truncating the y-axis both at top and bottom, we're exaggerating whatever's going on in the middle. Okay, so let's have a look at that. Okay, so there we are. That's a different view of the thing, right? So it's showing the same sort of crossover, but not in quite the same way. And this is the 18 to 29-year-olds. So these are the people, the age group that are likely to be impacted by it. Okay, so the age range, is it people to whom it will make a direct difference, or is it others? That makes a difference. If we look at here again, we have, all right, so this is the same sort of idea going on, but it's a rather more nuanced picture. Here we're going from 20 to 62%. Okay, if we look at the same data plotted out, okay, so what we see here, I think, is a very clear trend. Okay, so you've got this major increase through the late 90s of the pro-life people and a corresponding decline in the pro-choice people, and then it trundles along, and then there's another bit of a shift around 2010, 2011, and then some signs of that. So if we look at the overall proportions, if you think about those trends in relation to the overall population, then yes, there are changes. That's the big change. But after that, there's really quite an argument saying, look, you're between 40 and 50% everything, and it's saying it's roughly split, which is not the message you get from the other graphs. Okay, The other thing you do is you use emotive images. You'll overwhelm with detail. I will not show the image behind that blank. Okay. Right. Okay, so what else can we do? We can be selective in our time interval. All right, so here we go. Right, so this is climate science is rubbish graphic. So what it's saying, oh look, so let's take it from sort of 1950-ish, right? Okay, so there we go. There's our official temperatures. If you just look from 1950, you can still see it's coming up. Right. Okay, so there's your sort of current at that moment, and what they're arguing again. The where it goes out, right? Okay. So again, it's trying to show, oh look, these predictions, right? So again, it's staying within prediction. Okay, so we're including lots of short-term detail, and again, if we look at this over a longer period, we can see that the rise much more clearly. If we look at the predictions rather more accurately, then what we can see is that essentially what is happening is well within the range of what even the sort of late 1980s models were producing. And if you think, these are climate models, you've got loads of people working hard on them, you've got a doubling of compute power every 18 months to 2 years. So you're building more and more sophisticated models, you're getting more and more data in there, and all the early predictions are basically staying up. I think the other trend I would notice in this stuff is that the outcomes are actually consistently at the high end of the predictions. Okay, so I think the way I'm reading it is that the models are doing a decent job, but if anything, they are underestimating. And certainly the IPCC report this week got rather drowned in Ukraine, is starting to make the same sort of point. Okay, so what are we going to do here? We want to show there's nothing going on. Okay, so what are we going to do? We are going to only pick the data that helps us. It doesn't matter if it's not very good. If it helps us, it's fine. Okay, so if the satellite data helps us more than the measured on the ground data, let's use satellite data, or vice versa. If we've got minor issues in the data, make a big fuss about it. Okay, so, oh look, if we're correcting for instrument bias, that's a lie. So a classic here is that looking at the sea surface temperatures across the Atlantic from the 1940s onwards, you get a sudden shift in the middle of the 1950s where things appear to get a chunk warmer. What's happening? Oh, look, actually, ship design changed. And what was happening was that the temperature sensors were picking up hot water, some heating from the engine wastewater, the engine cooling water. Oh, look, a change. So again, this means the whole thought's, no, yeah, it puzzled people for a few years, but once you understood what was going on, it was quite easy to do the correction. But you had to do the correction. You put a new satellite up, it'll have a slightly different measuring system, and therefore you have to correct for that measurement. So it's normal. All statistical series have this sort of thing. Okay, but again, if you choose to make a huge fuss about it, and again, you're saying COVID is nothing. There's nothing, and what you focus on is, look, everybody reports the death rates in different ways. The fact that everybody reports the death rates in different ways, and they still all do the same thing, that's not the important thing. Okay, so minor issues. Right, okay, so there's loads on climate change. I won't go into any more here. Okay, so here, we've looked at deception, we've looked at variable quality reporting. If you're trying to communicate, at what stage does emphasis shade over into deception? Okay, so here is a graphic showing British naturalisations in the EU from 2010 to 2017. Okay, now it's done by a reputable organisation. Now you say, okay, what have you got? It's all looking quite good. So we're starting at 0. We've got top X, so there's nothing wrong with that. We've got it stacked, so we've got the smallest at the bottom coming pretty much. Okay, so we're not going to really quibble about the way those are stacked. There's all sorts of ways of doing it, but this is as good as anything because essentially you're ranking by numbers. Yeah. Okay, so the issue would be that normally you'd expect a stacked bar, but the data journalists here have used a stacked area visualization. Now, the stacked area gives a stronger visual impression. Now, so you can say it's more dramatic, but is it distorting the data? Now, it's giving a stronger visual impression, but is it distorting data? Can you read the figures off? Is it more difficult to read the figures off here than it would be in a stacked bar? Not really. So there's there are things to think about here. Okay, so it's not that's deceptive, that's not. There is this shading in the middle, and I think this illustrates it quite well. Okay, right. Okay, so some references, and that's what I want to talk about there. Okay, wait for my screen to come back. So the comment in the chat that the screen refresh is very slow, it's very true. That was a big gap there. Okay, so what I want to do next is I want to say something about controlling high charts with JavaScript. Wait for it to come back. Okay, put it into that mode. Okay, so we've got a new lab exercise this week. It starts from the same place we got to with the World War I casualty data, except we are using different data. We are in the world of the OECD gross domestic product data. And the measure we're using is gross domestic product per hour worked, per head of population, okay? Normalized in US dollars. If you look at the raw data set, which I'm happy to share with anybody who wants, there's 8.5 megabytes of it, and it's horrid. I downloaded it and cleaned it up for your benefit. So it will be worth talking about data cleaning later on. But I think the important point I would make about this is, okay, so this goes back to John Gall in 1975, how systems really work and how they fail. A complex system that works is invariably found to have evolved from a simple system that worked. A complex system designed from scratch never works and cannot be patched up to make it work. You have to start over with a working simple system. So this applies to the lab exercises. It will apply to your visualization project. Okay. The message is very much do something simple, save a copy of it, figure out what you want to do next, start doing it. If it goes wrong, say, oh dear, you can throw that bit away and go back. Okay, because you know you've always got your simple working, your last good working version to go back to. Right. Related to that, I would say that when you're saying, okay, I've got the simple one now, I want to do something different with it. So when we were moving from line charts to polar charts with the previous exercise, what we're looking at there is, okay, have a look at the example from a polar chart. And I think where quite a few people bumped their noses was in thinking, oh yes, let's just capture everything that looks different in the new one and bring it into our one. Okay, so a maximal approach. Not a good idea, okay, because you ended up with all sorts of bits and pieces that were either not needed or very peculiar or got in the way. So go the other way. Say, okay, I look at this example. I can see one or two bits that look as if they ought to be really pretty critical. Something that says polar true. Well, if that's not relevant, then it'll be astonishing. So let's put that in. Something that says pane and talks about angles. Well, it's a polar graph, so it needs something about angles. That's fine. Put that in. And at that stage, that would be where I said, okay, and now do a test. What's happened? Do you have anything that works yet? And you could, so then I mean, say, okay, now that doesn't work. What else do we need? Do we need something else? Is it that? And this is probably where you think, okay, this might be a good idea to go and look at the documentation or another example or something. But if you are saying, okay, I think it needs that, then you do that, test it. Is it working? No, it's not. Okay, put that to one side and look again. But once you've done the couple of obvious things, it's usually better to go and read more documentation if it's not going, because it's usually quicker in the end. Okay, system development, but do something simple, make a small change, test it. When it works, move on. Always keep previous versions. Strong messages. Okay, right. So what do we want to do? With this, we want to display multiple charts. We want to select which charts to display, and we want to change the chart layout or type. Now, what we're going to do to start with is display several charts. That's what the focus is for this, and we are going to put in a bit of infrastructure which will help us with chart selection later on. Okay, and again, we're going to put in something which will help us when we want to do the third thing. The main focus is displaying several charts. So what are we going to end up with? By the end of this, we are going to end up with something that looks like this. Okay, lots of little boxes. Right. Okay, so we've got we've got a header. We've got one of those already. We've got a display area. Yes, here I've called the things. Previously, when we were doing the casualties, we had years. Let's call them chart box because that's a better term. Okay, so we've got the chart in the chart box. The chart box is in the display area. We've got the header, and we've got a box where we're going to put some navigation, some menu later on. So for the moment, all we want to do is put the box there. We'll come to it later. Right. So if we want to do this, we need to understand something of how things are positioned, the CSS box model. So quick recap from last week about sizing, absolute or relative units. Right, so pixels being absolute units, percentages, m's and x's being relative units. Okay, so proportion of the window or positioned bounding box. So, okay, right now. So the bounding box for chart boxes here is display area, right? The bounding box for everything else is the screen. Okay, but this display area is going to be an important bounding box for us. Okay, so, right. And if anybody wonders what pixels are, there we are. I'll give you a definition. It is recommended that the reference pixel be the visual angle of one pixel on a device with a pixel density of 96 dots per inch and a distance from the reader of an arm's length. Great. There are multiple definitions of pixels. We will not go on into them. Okay, but just to know that that's what they are. Right. Okay, so first of all, we first label things. So we have the HTML, the ID attribute and the class attribute. So we've had ID equals something. We've done those quite happily. Now, what we want to do is to have a class chart box. Because we're going to have loads of the things, it would be nice to be able to control them as a group. Okay, so there we are. We combine div ID equals chart, one class equals chart box. Very common sort of construction. And then we can have rules affecting our chart box. Okay, we might have something that looks like that. Okay, right. Now, in our CSS box model, everything is a box. Okay. Now, when you need reference material on anything to do with HTML or CSS, usually if you Google for what you want, you'll find a Mozilla.org page, typically about 6th in the list. Go for that one. Okay, that's the explanations are nice and clear. It's reliable, definitely preferable to W3 Schools. Okay, right. So, what have we got? We start in the middle. We've got some content area. Okay, so the content here, this is where our graph goes, our text goes, or anything else goes. Right, now, if we come outside that, okay, we have some padding. And the padding comes between the content and the border. Right, we've been conveniently giving our text boxes little coloured borders so that when we look on screen, we can see where they are. Because if they didn't have by default, they don't have a coloured border at all. So giving them a coloured border just makes our lives easier as developers. Right, so there's the border. Outside the border, we have a margin. That's fine, okay. So those are the elements of our box. When we specify a box width and height, that refers to the content area. So border, margin, and padding are on top of that. Okay, so we can size and position our boxes. Okay, so we could, if we wanted a decent margin around everything, we might say, look, margin 1em. So, at each side of our box, that would give us a margin, the width of the lowercase m in the current font and size. Okay. So that current font and size matters because if you have an m in say a header box, it's got to have big titles in it, and then the lowercase m in that font and size is going to be quite big. Whereas if you've got a 1em in a margin in a menu, then that's going to be some normal size and it's going to be a lot smaller. But it does mean that they're consistent as the screen size, as the text size changes, nothing breaks. We could say, okay, we'll have a left margin of 1%. That's 1% of the bounding box or the screen we're whichever it happens to be. Okay, you can take the screen as the ultimate, or the window rather, as the ultimate bounding box. Okay, so, and then our padding between the edge of the box and the text, right? So we can therefore say, oh look, we've got this div, we'll make it 20% of the whatever it's in. We'll have a margin of 1% of that, and we'll have padding of 0.5 m. So all sorts of things we can do depending on what we're trying to achieve. Okay, now on CSS positioning, there is a huge amount. What we are going to do is to show you one way that works. Okay, there are many, many other possibilities. So there are 4 ways of positioning boxes in CSS. The default is they're called static. You can have absolute position, which we'll use, relative position, which we'll use, and fix, which we won't use. Okay, so our absolute position says relative to the bounding box, we are going to tell that box exactly where it has to be. Okay, and relative is relative to some other box. Okay, and fixed is in relation to the window as a whole. Right, okay, so what might we do? If we wanted a classic old-fashioned 3-column layout, we might say we'll make the left margin 1%, the left column 15%, the right margin 1%, the right column 30%, and let the center be as wide as possible, and just say we'll give it 1% margin right and left. By not specifying the width of the center column, it means if we change either of these two, we don't have to worry about consequential changes breaking something. Okay, so here we go. If we put that into that simple layout into CSS, that's what we got. So position absolute in each case. Right, now positioning in high charts. What we are going to do is to say we are going to have a relatively sized display area, and within it we are going to absolutely position our charts. Okay, so we're going to have display area as a relative size and position. We are going to have within that chart boxes which are absolutely sized and positioned. It's easiest to work in pixels because at the base level, high charts obviously is relying on some built-in drawing functions, and in the HTML standards family, this is SVG, which stands for Simple Vector Graphics. So if you think of an old-fashioned plotter, at its heart, SVG says, okay, what have we got? We've got the operations move pen up or move pen down, draw. So okay, so moving pen up gets you to a position, going pen down and moving gives you a line. If you do a sequence of lines, you fill it in the middle, and that's essentially what SVG is doing. It's quite clever and gives you a bit more than that, but at its heart, that's what it's doing, and that's what high charts at its lowest level is relying on. Now, we don't have to engage with it at all, but because SVG has got this notion of moving around a rectangular grid in what it thinks of as pixels, this is why we get pixels reflected further up. Okay, right, now, how do we size a chart container? So this is very much a core thing in this week's lab exercise. So what are we going to do? Right, how big is this thing going to be? Well, first, how big is its bounding box? Okay, so the first thing we're going to want to do is to find out how big the display area box is. Okay, I'll look at the detail in a second. Then we're going to decide how many columns to have and what the aspect ratio of our chart boxes should be. So we are going to work to start with 3 columns, and we're going to work with 9 to 16, 16 to 9 ratio boxes. Okay, 16 to 9, 9 to 16 is a nice ratio, sort of ratio you've got for slides and screens and things. That's fine. Right, so we'll get the width of the bounding box because we can, okay, in any element in HTML, we can query it through JavaScript and find its width. So we can just say, what is the width of the display area, and we'll get an answer in pixels. All right, that gives us a number. So we have a number. Okay, so we can say that width divided by the number of columns we want will give us the width of our boxes, and we know that the height should be 9/16 of the width. That's great. So we can add CSS rules to our boxes, to our divs, using JavaScript. So we've seen a little bit of sort of that syntax of $hash append. Okay, so instead of doing $hash append, we're doing the same thing, but we're saying CSS, open brackets, and then we're doing the property and the value. So one line, one rule. So if we want to define the height and width, it takes us 2 lines to do it. Okay, so in a CSS rule and style sheet, we can have multiple rules in the same rule set. For when we're doing it using JavaScript, we can only do one at a time, but that's fine. So it's a minor thing. Right, so it's not that the calculation is difficult, it's just you've got to calculate the right things. The other thing that we will do here, and it's explained a bit more detail in the lab sheet, is we will round these numbers downwards, because otherwise we're going to end up with horrid little fractions of a pixel, and that's not going to be helpful to high charts. Okay, so let's do the rounding ourselves, and we know we've got control over it. Right, so that's fine. We can find out how big the thing has to be. Now we have a slightly more interesting thing. How are we going to place them correctly? Okay, so right, so we're going to place our chart boxes absolutely, and what we want is to know what the distance is, what the height and width is from the top left-hand corner of the bounding box. So how far away is this box going to be from the top left-hand corner of the display area? Now, given that we're in a loop going round and round and round, so from 1 to the number of charts, from 0 to the number of charts we want, we're going round this loop. So we know which chart number we're on. That's really nice. We know how many columns we've got. Okay, so if we know the chart number and the number of columns, we can divide the one by the other and look at the remainder. Okay, so if we've got a 3-column layout, we're on the 5th, so we say, okay, for 5, the remainder of 5 divided by 3 is 2. Okay, so you've got either remainder 0, 1, or 2. Great. So that's fine. So that tells us where things should be. Right. Again, we can do a similar thing. We calculate which row it's in. Again, the thing to remember is that if we start our counting from 0, it all works. If we start it from 1, it gets a lot more complicated. So start from 0. It's all very nice and simple, which should be reasonably familiar, I think. Right. So we can find out the column number, the row number. We multiply by the width or the height of the container, and that says, okay, tick, done, we can do it. Now, onto that, if we want to get our layout precisely, we should add any border width, okay, because that border is in addition to what we've got. Right, minor thing, if you don't do it, you'll think, oh, it doesn't look quite right, go back and fix it. So there we are, there's a reminder of what we're looking for. Okay, so we can quite happily do things with a header, format that a bit. Okay, we might call it dataset title. Okay, so that's what we're aiming at. And then if we get there this week, we can have a look at various data sets. And then next week, we can concentrate on putting some control buttons in here to allow us to change the number of columns and the things which charts we're actually going to display. So, okay, so this is the simple thing, and we're going to make it a bit more complicated next week, right? No, it's fine. It will work because we're doing one thing at a time, right? If we've got one working thing, oh yes, now we can build on it. If we try and think, okay, now we want to go from doing a single chart, we're going to do this huge thing all in one go, it won't work. Great. Okay, so on that, I will stop and wait for my screen to come back. I will come back over here. I will stop sharing. I will